Hi, Bile. Yeah, we don't have that. It's not a function. What's this one? Sorry, Bile or more than 30 years. I have no idea what to pass as viewport. Viewport. I think the description said what it was. Bezier segments that fall entirely outside of this viewport will be discarded. Normally you would pass plot viewpoint. Oh, that is the, yeah. It's not in pixels. That is just the axis that you see. Right, so my attempt is as follows here. I can of course, I create a Bezier curve here. The whatever Bezier curve. And we can of course draw that one using in the plot dot create Bezier curve, which then will draw the thing because plot is involved. But I want to use Bezier fitter instead, so I'm faking a function that just returns a point at a parameter t of that Bezier curve. And then if things work out, then this function should be called for 0, a half, and 1, just 3 times. And I'm not sure what is going to happen then, because you can fit any number of Bezier curves through the 3 points. So I guess we'll see. I probably want to see when it is being called though. The point here is just assuring that the thing returns a point, but it should already be derived from the fact that p is a point. Maybe it's not even needed. Well, wait a minute. This is my lambda. No, that totally does not look nice. The whole indentation is missing. That puts a lot of the new line, so now we have an indentation. My indenter is getting a little bit confused here. So I can see for which t values this is being called. Big step if it compiles. Yeah, the lambda needs to be able to access these things. So t is just parameter, and it seems that Bezier curve g little the only thing. We have that here. I'm not going to make a copy of that. Should just make use it as a reference. Use it by reference. Lambda stores a reference to that thing. Nothing. So yes, it is being called for 0, half, and 1. And then we call Bezier fitter solve, which calls it for Chebyshev points. So these are 2 points in between 0 and a half, and two other points in between a half and 1. So then together we have 7 points. And yeah, why am I not seeing anything here? Shouldn't that be drawing something then? I think I'm just literally not plotting it. The thing is being constructed, but we still have to add it to the plot. So now I created a plot Bezier fitter. And I have to do something with that, I think. Let's just look at existing code. old curve. Yeah, okay, so we call solve on it, and then you still have to add it. Haha. Adding it to the plot makes it being drawn. I did call solve on this thing. It should already work. Wow, I'm surprised how accurate this. That already fits very precisely the previous thing that I had, which was. Oh no, of course it does. Sorry. Yeah. No. This is just the exact same Bezier curve that we had before. The calling of the lambda doesn't do anything. I think the only thing that it does is to then check if these points are on the current curve, and then say calculate the error. And then if the error is too big, it wants to split it up. The error is almost 0, so it does not try to split it up. So if I just if I change the lambda to return something nonsensical, like no, 0,0. I think it should work because it knows that it is a point. So if I do it like this, it's going to try to construct a point from 0,0. Or not. I'd expect it to get still the same output. Probably here are our zeros. So this thing is called 3 times. Now we call solve on it. Well, x runs from -10 till 10 and y as well. These are simply these values. And you only use that to not draw anything when it falls outside of that completely. I don't know anymore what that was. Yeah, this 0 here is this 0, and this 1 here is this 1. And then just the half is just the thing in the middle, I think. It's kind of weird though that this is printed before I call this. Oh, this is printed, this is called from the constructor of the Bezier vector. Anyway, these 3 points are, there's a parenthesis missing here. Those 3 points are what is returned by these things. I don't understand why it's not drawing something anymore. Definitely misunderstanding something then. missing parentheses. So we enter this function. Oh, yeah, I'm getting it. Sorry. Yeah. Even though the underlying function is now a Bezier curve, it's still going to construct its own Bezier curve based on the points. So this is just not working unless I'm returning something sensible. In which case, it is surprising that the curve is looking so good. I think, but well, so much better, I suppose. Let's just try to... No, let's just use this. So this gets values for a point at t, while this Bezier curve used 2 points, P0 and P1, and P gamma, I think, although that thing called PG is being used here, from which you get an alpha and a beta, from which we get 2 control points. And that the control points are using D0 and D1, which are direction vectors at t is 0 and t is 1. I'm wondering if I could tell. It's in the description. I was wondering if I can get rid of this direction here. So now we have a direction vector. So that's a unity, a vector in the direction of the, say, the velocity of the curve with a length of 1. Direction is a unity vector. If I would just remove direction here, we would instead get actually something with a rather arbitrary length. That's just going to be the radius of the circle that I chose. So this is just a freely chosen diameter. Apparently the radius is 2, from -6 to -4. So the vector, there's no label here, but this is Q0 that I can drag here. So the vector q0 minus p0 is has a length 2 instead of a length of 1. But it's still rather arbitrary. Nevertheless, calculating creating a direction vector, it's requires calculating a square root, so I would like to avoid that. So you can find that. So this one, probably. So it calculates the square root of the length and then divides the x and y coordinates. So the result has a vector of the length 1, but if you can avoid that, you could separate this out in 2 variables. That gives me the length. I can make a vector that just this vector, and then another variable that says what the length is, which is always 2 in this case. That then has an influence on A, because that's the only one that this matrix contains the D values. So that means that D0 is multiplied, so this column of the matrix is multiplied with one vector and the other one is multiplied with another vector. And this solves not enough comment here. I don't know what it does. Yeah, this is the standard syntax. We're using the eigen library, so I suppose the comma operator is executed first. I don't even know. Maybe they made it work anyway. You can also just return some type here, which then remembers that you started writing. Okay, let's ask ChatGPT. And that's why I can't see it. I thought they had a dark style, didn't they? There we are. Yeah, well, I found it back. Okay, let's see what it said. And it often solves a linear system to find scalar multiplies alpha and beta associated with the vectors d0 and d1, given certain points p0, p1, and pg. Here's a detailed explanation. Given the vectors assumed to be 2D vectors, points, components, objective, find scalars alpha and beta such that but why? This is it. Wow, this is like magic. Till here I had the feeling like this is not going to help me one bit. And then it came with interpretation in the context of Bezier curves. Is that in my code? Look at this. This is a new instance of ChatGPT. And I'm not mentioning Bezier curves at all. And it just guesses that it is related to Bezier curves. Wow. Okay, this is very, very good. Impressed with it. Well, normally I'm really, I mean, it's just shitty, the whole ChatGPT, don't get me wrong, but this is exactly what I wanted to see. So yeah, so it is guessed that the P1 and P2 are control points, where D0 and D1 are tangents in P0 and P3. That is shocking, man. It just sucked it out of the sum, and it's correct. That's really amazing. That was not part of the code at all. But it just got it. Wow, yeah. So yeah, the control points are on the tangents or through P0 and P3. So these are the definition of the very definition of the control points. If you want to express them as an offset relative to the begin and end of the Bezier curve, and then you just have to calculate A, alpha and beta. And then we also demand that the curve goes through P gamma. So, and it guesses that that happens at t equals a half. But okay, that if you have to guess something, then that would be a logical guess. Just go in the middle of the 0 and 1 here. And then yeah, this is just the formula for the Bezier curve. So you get 1, 3, 3, 1, and then I guess the half turns into 1/8 for each. And then we substitute the control points, work that out, and you rearrange it, then you get that, and that's what you're calculating. That's what you're trying to solve. That is definitely very impressive. Yep. Yep, that's exactly it. Wow. Okay, so now I want to understand again, why are we having alpha times d0 minus beta times d1? That's because it pops up here, and that happens because this 1/8 combines with that 3/8 to give a half. And that happens also for the P3. So this includes the offset, the begin and end point, which is, say, the starting point of the well, how do we say that? The alpha d0 is an offset relative to P0, which is done in here together with the rest to get the Bezier curve formula. Okay, so I think I can just ignore the length of d0 and d1. So they have a certain length, but I don't need a direction vector with the length of 1. Because whatever that length then is going to be part of alpha. And here it's going to be part of beta. So they just cancel out, well, they don't cancel out, but I can just calculate an alpha and a beta with an arbitrary vector. And that has then direct influence on, a linear influence on the value of alpha and beta respectively. And then we multiply that alpha again with the same vector. And then you just get the same offset again. So d0 here is an input. Huh? The thing that I really hate is that if now I ask, do you think that it is so that if we multiply the d0 vector with a vector of 2, yeah, I should put it, if you give it the answer, it's just going to say, yes, you're right. I should ask it as a question. what happens to the value of alpha and or beta if we multiply d0. No. There's some constant k. So I think that means that alpha is divided by k. What the fuck is that? Okay, so yeah, I was right. The new alpha is just alpha divided by k. Yeah. So we don't really need a direction vector. I'm just going to use a normal vectors here. And we'll call these I just still call them D. Why not? Let's call them T. T for tangent. More like calculate. I mean, these are just simply these vectors here, like this orange vector. They have an arbitrary length because I picked one, and it happens to be 2. But this vector here, that's what I have there. That at least that would be this one minus that one. Then we have this vector. Otherwise, it would point the other way. So to work with this, we need Q minus P. And that's what I have here. Maybe I should copy the reasoning that we just got. This is just P gamma, right? In the end, we want P gamma to be this. So note that P a half. Sorry, to blob. Okay, note that we want P gamma, that's PG, to be P a half, which is given by, and then I can just have a quick look at the Bezier curve formula. copy the whole thing. I can do that better. Let's just go for 1/8. Shit. Kan te lang doen. want to have this one. Yeah, that's just this side. Well, this is the other side. Well, A alpha beta. To the matrix A times Yeah, so I just simply removed the direction here. So you're no longer dividing by the length, no longer need to calculate the square root. I just take this with an arbitrary value, which then has an influence on alpha in a way that after multiplying it again with t0, it simply becomes the offset for c0. And the sign of alpha and beta doesn't change because you have to check that they are both positive. So this is totally going to work. Yep. Now let's see, what did I want to do? I have a Bezier fitter and then we do stuff. And I have a plot Bezier fitter and we add it. Where's my solve? Oh, the solve is here. Yeah, that must be part of the Bezier fitter, of course. I don't see it. Let me think. Can only created by moving a Bezier fitter. But we'll use this dough. Okay. So I have a Bezier fitter here, and then I do stuff, and then we draw it. But what I would really like is that this stuff is hidden. So I'm going to call solve. Well, I'm not calling solve. I'm going to pass all this stuff to the constructor. And I think I can already do that. What is the problem here? The problem is that this Bezier curve must exist. It is now pre-calculated. Here. Yeah, I think what I need is to, let's begin with I'll just get rid of this scope here. So instead of passing it to solve, you can pass it to the constructor. This is what I'm calling then. This is the constructor. We just call solve in turn. This should still work. But the annoying thing here is that it's a bit confusing that this function is a Bezier curve in itself. Maybe you should just try to draw a circle. Let's say I'm not going to use Bezier curve here. I'm going to return a point, and that point is yeah, but just something around 0. So you can use cosine. So this should draw a complete circle when t runs from 0 to 1. But let's just draw a half a circle. Let's go from a quarter till 7.5. Nothing, damn it. simply not understandable, these values. I would say this is the one from a quarter. How the hell is that 0? So we should get a circle with a radius of 1 around 0. So not this, but half the diameter. And this is just the angle relative to the positive x-axis, t. So this is 0, and then 1. So this is a half. Oh, it is correct. This is a quarter. I thought it was something halfway. So we go from a quarter till 3/4. So yeah, that is 0, 1, minus 1, 0, and 0, minus 1. So there's almost 0, 0, minus 1, and here we have minus 1, 0, and 0, 1. So that these values are correct for these values, or well, for these values. But it's not drawing anything. Why is that? Oh, because I'm drawing Bezier filter. Oh, no, but it's sorry. I thought I was confused with that one. No, I changed too much, I think. Or maybe let's change this back, because I thought that would still work. Then let's return the Bezier curve dot p at t. No, I changed the domain still, but that should work, shouldn't it? Yep, that works. So instead of starting at 0, it starts at a quarter. Till 3/4 instead of 1. The problem really is just the function values, apparently. I don't see why that would not work. Let's make it a bit bigger. Nope, still nothing. why not? These are clearly all points on the circle with a radius of 3, which would perfectly fit here. This circle here. And we don't get anything. Why? More debug output. Can't type. Deep C WD. It's not even listed anymore. You think I could remember that or something? Okay, the Cairo. Something, maybe. Cairo. Cairo window as well. The fitter is not drawing anything. It's not fitting at all yet. It just wants, I just wanted to draw a single Bezier curve. Maybe it just fails to do that. I don't know. I think Cairo will be enough. We'll just we get to see all the Cairo calls. It's a lot of debug output though. Clearly it's not calling a single Cairo thing. I mean, all of these are before this, so that they can't have anything to do with the Bezier fitter. And there is nothing here, so it's literally not drawing anything. While if I put back this thing, which did work, then we should see a lot of debug output for Cairo calls. Yeah, maybe that's the reason. Yeah, probably. I think the tolerance is not good enough, and then maybe that's why it doesn't draw anything. So probably it. Oh yeah, so here you see that it's actually drawing something. Okay, so the problem is probably in that must be in this constructor. So plot Bezier fitter. Just uses the base class constructor, which is then this one, which calls solve. And then I suppose we try something. If the curve is entirely outside the view, but don't bother rendering, so that could happen. The spread is very large in either dimension. We need to be more careful, but in the end we might just return. I think that happens then. We need to get here. Maybe you don't even get here because of this, that the tolerance is not good. Ah, yeah, of course. So the tolerance is not good enough, and then normally it would split the function up. But I suppressed that with this one here. You always return. So if the tolerance now is not obtained, then we're drawing nothing. So I can put my 1 here, but I really should have to put the 1 here. Just never mind the tolerance, just return. This is wrong. Should never have gotten here in the first place. So I'm gonna do 1 here. As if we always hit the correct tolerance. No, not useful. Yes, now it works. Cool. Yes, you were totally right. You were a smart guy. I kind of feel stupid. It was, yeah, I could have guessed it as well. Maybe I'm just too careful. Making very small steps, but yeah, no. Okay, so this is my half circle with a single Bezier. Not too bad. The annoying thing is that, as you can see, it already works. I had this function, but I decided to improve upon it because in certain cases it didn't work. And I forgot in which cases. It really would have been helpful to have a case where it doesn't work. Man, I really feel old and I cannot remember stuff like that anymore. What the hell was it? Why did I decide that I needed to do this? The only thing I vaguely remember is that it had to do with trying to draw around a discontinuous step in the function. But I'm not even sure. What really goes wrong or went wrong, I remember that, is that the Bezier vector solve. Yeah, there has a depth, I just put in a depth of 100, which is completely insane because every time we hit, we increment depth, it divides the function in 2. Why would I go to 2 to the power 100 different functions, different Bezier curves? So that's nonsense. And then what happens is that if you don't reach the tolerance within a reasonable amount of time, let's say depth of 10, something like that, it just continues and continues and continues, and then at some point the points are so close together that it's just one big round-off error. And it doesn't matter that you go past the 10 or the 20 till the 100, it's just doing nothing anymore. So everything fails because it's just floating point around of error, so this always fails, so it doesn't add anything. It just keeps calling itself incrementing depth until we reach this, which then could get very slow, because every time it calls two functions. So you get literally like a half to the power 100, or I mean, it's just not calculatable at all anymore. And then I call 2 to the power 100 functions. This doesn't work. Now you say, well, no problem, just make it 10 and then it will work again. But that did not work either. And I forgot why. Oh, right. I think I remember now. The problem is that you kind of expect that eventually you cut the function in so small pieces that you do reach the tolerance that you want, which then would lead to something actually being drawn, you know, push back some kind of Bezier curve which is being drawn. But if you never reach the tolerance, then, well, like I just explained, it doesn't make any sense to try the 100 deep. If we stop at 10, then, well, you just didn't reach the tolerance, period. So nothing is being drawn. That is the problem. So I wanted to improve upon that in a way that if it reaches a certain depth, that it is still drawing. So what I could do is say, if the test here, if the depth is already too large, then do pretend that we reach the tolerance. And I try to write that, including making a distinction between the tolerance for the x and the y-axis separately. And that was a complete fuck up, so I reverted it. The last level, you mean? The last depth. So what I should do here is if the tolerance is reached, but also is anyway, rather, is the depth is already equal to 10. This also looks very, very wrong. We return here without decrementing depth. What's that going to do? At least that. What is that going to do? Causes to return from one of these functions. With depth one larger than it should be. I don't understand what you mean with fitting level. I ripped this code from someone, by the way. I didn't write it myself. So I'm not sure about the intricates. You can even see that because this is a residue and I would never abbreviate something. Or coefs. It's just not my code. If you mean how the X residue is determined. Let's see here. It's not very transparent, I'm afraid, this code. The only time I ever heard of Chebyshev was when I did electronics. That was a Chebyshev filter. That was an op-amp, I think. That how Chebyshev to Bernstein are related, I have no clue. So I don't really know the mathematics that is being used here. I don't think it's correct to return here without decrementing the depth, though. Oh, actually it is. Otherwise, yeah, that is the reason why it doesn't take forever, because it didn't really take forever. I could just use 100. If I would decrement depth again here, then we really are calling 2 to the power 10 now times this function, which would so now, but if the depth really gets too large, then I leave the depth that high, and then it's also really fucking up, of course, because I think then you return, I mean, this minus belongs to that one. Or am I mistaken? Well, actually you never get here anymore for depth larger than 10. This whole line now can be removed. Or so we don't return anymore. That's good. Yeah, half a circle. So how many times is called P now? quite a lot. A lot, actually. But yeah, that is then kind of required for getting a ridiculous accuracy. It's slightly annoying. I think you already get an almost perfect circle if you just use a Bezier, the one Bezier for the and 1/8 or something of the circle. So 1, 2, 3, 4 Bezier curves here. That would already be very, very good. I'm not really sure how many. Is that not curve 2? Yeah, that's a curve, so we can count how many curves we have. 1, 2, 3, 4, 5, 6, 7, 8. No, not that bad. Took 8 instead of 4, and then reached a very high accuracy, I think. A tenth of a pixel or something accuracy. So that seems to work fine. Okay, let's draw a whole circle then. It's easier to see. Perfect circle. You're again asking a question I don't understand, man. Purely shape approximation or preserving the parameterization? What do you mean with the last one? And like I explained, it's not my function and I don't know how it works. Do you know what Chebyshev base means and Bernstein base? Some kind of mathematical magic with stuff. But clearly it's a parametric representation, otherwise it's not a function, otherwise you can't call you can't draw a circle with it, of course. Okay, let's try one of the other tests that I think went wrong. Yeah. Too much Deepak output. Yeah, reach max depth. That's kind of weird. That probably happens because of the step here. I think. Yeah. See if I still have the code to zoom into that. Can't even break out of it. Probably this one. Nope. Not around here. This looks like a 7.7 something. So how did I not see that 1 second ago? Huh? 7.7. This is 7.7. So I use 0.1 and then I don't see anything anymore. Okay, 0.2. Oh, right. Yeah, okay. I've seen something like this before. I think it's just upside down now. This is not what is happening, right? Something is really wrong here. That just... What? So what goes wrong then? What is going wrong here? No, it's... it is going negative here. That's sort of an overshoot. It's ridiculous in itself. Now this thing exists of cosines and sines. So you have a sine, a piece of a sine here until the bottom, and then it switches to a different one. So from here to there is just a piece of a sine. And then after this point, it just returns 0, because it doesn't add a new part of a sine anymore. But it still tries to draw something. I mean, it knows that here it is like this horizontally, and then next it's 0. So yeah, it tries to fit that. But if I zoom in on this, we get something really weird. And sometimes some point it inverts, which is, what the hell? Weird. So let's try plotting this from 7.5 to 7.6. I already saw that at some point it does its thing at 7.7 something. I really have no idea what's going on. Just that it does not work. Yeah, but it's time for me to go to bed, so let's quit with that. And I can't go to bed before losing a game of chess, of course. Yeah, Clement, you're going away. You're leaving already. I mean, oh yeah, I see. Kotaro is leaving. Yeah, of course. Yeah, well, I'm leaving as well. So everyone's leaving. Let's come up with a move though. If I do this and I take, then I take back. But if I do this and I take my bishop, then it would be a bad thing to take like this, because I would get an isolated double pawn. And if I take the knight, I lose a pawn here. That's not what I want. So I can put my rook here. You could have done that. Then I had to put that. And then the bishop here. I was basically just screwed. Could go here and then nothing. Just develop the rook. Everything is defended by this bloody knight. No, this thing is not defended anymore. Near is that. Now it makes sense to go here. Yep, that is one in truth there. I don't know. It looks like I'm losing again. Still losing a pawn here. Damn it. Maybe this is a good move or not? Trying to take here. No, not any longer a good move. Maybe now. Do push, take, defend it. I think I can do it. Trying to take this pawn, which is a pretty nasty pawn. And then back in time to save the day here. Not entirely sure though. Nah, this king goes here. I take this pawn and I lose that pawn. Take, 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 take. And then I'm still a pawn down. Not this way. Yeah. Huh? Is that possible? Guess it is. Damn it. Probably the losing move. Yeah, this was bullshit. Just move this pawn forward, man. We can do it afterwards, maybe. Yeah, I'll lose this. Yep. I should not have exchanged rooks, of course, with the pawn down. It's just stupid. Always stupid. Why did I lose that pawn anyway? Black is better. Okay, so this is a draw because that is a losing move, seriously. Yeah, I should have stopped the king from coming in. No, it's a draw again. If I would play this pawn, or because then I can defend here. Aha. Tactics. Not only defend, win this pawn even. Strong move. Pawn f5. So the only way to keep this a draw is play the rook over there. Over there. Shocking. See what happens if I don't. The threat is this pawn. It's even worse. Can't exchange rooks. Well, this one, also on that one. Also that pawn. So it's definitely the threat here, this pawn. That exchanges rooks again. Yeah. Control this. Oh, it takes it. I'm so clueless in a game like this. No idea. Yeah. What was my last chance here? That was a good chance. And here again. Hook there. I really don't get this. Why? Why can't he play this trick? Oh, right. Oh, that's why. Go here so I can go there if he plays this pawn. It's even a pawn up now. I could have cut off the king like this and then threaten to take this pawn. Can't really attack me. Sure. Yep. Well, I should go to bed. Good night.